Welcome to EDU World Space.
For this problem, we are learning how to do some surface integrals and calculate surface area. So we know that our surface has the form z equals f of x, y, but in this case, it's z equals 1 plus x squared over 1 plus
Here's
y
a clean
squared.
and professionally formatted presentation of the calculation shown in the image.
The surface area, it's going to
Application
equal
of the
the
work
double
energy
integral
theorem, wet. From the work
of
energy theorem,
the square
force
root of
F is
1
given
plus
by F equals
the
frac
partial
text
derivative
KE,
of z with
where
respect to x
KE
squared plus the
equals
partial
kinetic
derivative
energy,
of y with z
S
with
will
respect to
stopping
y
distance.
squared
I'm given
dA.
for object A,
So
FA
first thing we
equals
have to do is
100,000,
calculate the
0.10.
partial derivative of z
For
with
object
respect
B,
to x.
FB equals frac
That's going to be
225,
2x
1500
over
equals
1 plus y
0.15
squared.
text space n.
And then the partial
force ratio
derivative of z
frac
with
FA,
respect to y
FB
is
equals
negative
frac
2y
0.10,
1 plus
equal
x
frac 2 null
squared
result of a
over
box frac FA, FB.
1 plus
Would you
y
like a
squared
PDF version
squared.
of this explanation?
Then with this, we square these two values to get area. It's going to be the double integral. And what we'll get for the limit based on what we have, since the absolute value of x plus the absolute value of y is less than or equal to 1, our bounds of integration are going to be, in this case, 0 to 1 and 0 to 1 minus x. So these are, if just out of curiosity, if you were wondering, this is the bounds right here, but we also have to recognize that it occurs in all four quadrants. So it's going to look like this. So we're going to put a 4 out in front because we're just representing this, but we need to multiply that by 4. So on the inside, what we'll have after we square everything, what we end up getting as a result, and we can move this down to give us more space. What we're going to have is there we go. We'll move this down here, and what we have is 1 over 1 plus y squared squared times the square root of 1 plus y squared to the 4th plus 4x squared times 1 plus y squared squared plus 4y squared times 1 plus x squared squared, and then dA. So when we evaluate this big integral, oftentimes it's easiest to use like a calculating tool or something like that, just to deal with these massive integrals. But when we approximate it using this calculating tool, what we end up getting is approximately 2.6959. So that would be a good approximation for this surface area. And remember, this is area, which means it's going to be in units squared.